We're in our course home page on Fundamental Mathematics Section 1. And we're looking at the menu choices over on the left. And we're going to select Homework. Now, this window opens and we see we have things that we did earlier, but right here is Review for Final. It's not required, but this is what I'll be working on today. And there are 100 questions. Now, what I thought I'd do is divide this into 4 parts, maybe 5 parts actually. I'm assuming that questions 1 through 20 will be the ones dealing with Chapter 1 and so on and so forth. Now, what I'll do is go over the strategy for this and maybe a little background as we review for preparation for the final. So let's click on the first one and see what we have. And I'm going to open this up. And there it is. So what we'll do is look at these and just see the nature of them. And I may or may not answer some, but I'm going to definitely look at the theory or strategy behind it. So first of all, is this statement true or false? And it's that 3 is less than or equal to 3. Well, in this case, if part of it is true, then it is true. So we'll click True. And we got that one right. Let's go on to the next one. And we may have to adjust the screen a little bit here. The highest elevation in a country is a mountain with this altitude. The lowest elevation is a valley with this altitude, this many feet below sea level. Okay, the integer represents the mountain altitude represented in feet. Well, all you would put in there is this number right here. So this is the altitude, and basically what they're looking for here is whether it's a positive number or not, and this is. And I did that. Let's check our answer. And we got that one right. Now, here we're looking for the integer that represents the valley's altitude. Now, since this is below sea level, that part's cut off a little bit, we just put in a negative value for that. And we got that one right too. Now, for this one, we're looking to see which set of numbers the square root of 6 applies to. Is it a whole number? No. You recall whole numbers are 0, 1, 2, 3, 4, and so on. Now, all numbers on the number line are real numbers, so this is a real number. And is this rational or irrational? Well, anytime under the square root sign you do not have a perfect square, such as the square root of 4, the square root of 16, the square root of 25. Those are all perfect squares and would become an integer once you take the square root of them. Then all these other numbers are irrational. So it's not rational, it's not an integer, and it's not a natural number. So this is, again, chapter 1 stuff. Now here we're looking to insert these symbols to make the statement true. And we find these numbers are within absolute signs. So to really do this, first you would have to actually do what they're asking you to do, which is what's the absolute value of -7. And any absolute value is always the positive value. And then now that we've carried out the function, the operation of taking the absolute values, here we see that 7 is greater than. So that's what we'll put in there. And I guess we go right there. And there's our symbol. And we got that one right. Now here we're asked to write the number as a product of primes. Well, a strategy for doing this would be to make a prime tree where this is even, so we know we can take 2, and 2 is the lowest prime number, or it is a prime number. So 2 goes into 50 25 times. Now 25 is not even, so no 2 will go in there, but it ends with a 5, so we know a 5 will go in there, and 5 is prime. So this is the work to support this answer. These are now all prime numbers. So we'll put that in there. And we go 5 times 5. Now I probably should have put the 2 in there first, but that they should accept this. I would. And if they counted it wrong, I would give you credit. And they are accepting it. Okay. Good for them. All right, we want to do this one because fractions and the rules of fractions, very important. So this is a division of fractions. And for this, you need to be familiar with the rules. And the rule is we write the first term down like so. Now, we don't do division. We always convert division to multiplication. And to do so, we flip our second term, that is, take its reciprocal. And that is key to doing this. So now we can cancel. 7 goes into there once, 7 goes into there twice. So our answer is 2/3. So we go over there and put our fraction in there, and we go 2/3. And we have that one. Now, for this one, we are asked to add. And notice the denominators are the same. So the rule would be just add our numerators. So this gives you 15 over 111. Now, if you put that in there, and I will, they're going to count it wrong. And I'll tell you in just a moment why. But I want you to show. So we highlight this, put in our fraction, and we get 15 over 111. Now I'm going to check the answer. It's going to be incorrect. And you might say, why? Well, because actually that could be simplified. So we had 15 over 111. We said we did it right. Why isn't that correct? Well, if you remember this, the rule of threes. If we add up our numerator, we get a 6. If we add up our denominator, we get a 3. That is 1 plus 1 plus 1 is 3. 1 plus 5 is 6. Now, if this meets the rule of threes, this can actually be reduced. So we can say in our 15, we can factor out a 3. So we take a 3 out of 15 and we get a 5. Now we take a 3 out of there, we get a 9. So in 11, 3 goes into 11 3 times with a 2 left over, and 3 goes into 21 7 times. Again, this one's kind of tricky, but it's needed to simplify fractions. This looked way too easy, and again, you did the right thing, you just didn't simplify. And the rule of threes is critical here. So 3 goes into 15 5 times. And another way to do this one, by the way, is 111 divided by 3. So 3 goes into 11 3 times. 3 times 3 is 9. Now subtract that, you get a 2, bring down to 1. 3 goes into 21 7 times. So this answer is going to be 5 37ths. Let's check that out now. And put it in there. And now we have it right. Okay, let's go back to this one. And again, these are very typical of what you're going to get on your final exam. You don't know which one, so you need to be familiar with them all. So a strategy for doing this subtraction is you write the example out. And now the denominators are different. So you need to say, well, what's my common denominator? Well, it happens to be 40. Now, if my common denominator is 40, I need to make each of these fractions into equivalent fractions by multiplying them by 1, but in a form that will give my denominator, or make my denominator a 40. So here I have to multiply this one by 5. And the one we're going to multiply this by is 5 over 5. And for this one, we're going to multiply it by 2. And our 1 here in this fraction is 2 over 2. So now 8 times 5 is 40. 5 times 5 is 25. 20 times 2 is 40. negative 9 times 2 is 18. So now we do our subtraction. 25 minus 18 is 7 over 40. Now keep in mind that on your blue sheets, as you take your final exam, you want to write out the work neatly and clearly, as I am illustrating here, because I can give partial credit for the work, and I see you just made a little error somewhere. Okay, so we're going to put in 7/40ths there. And we check our answer. Okay. Now, again, this is a technique we had worked on a long time ago now. And these are compound numbers here, or mixed numbers. We need to convert them into improper fractions. And the rule for it is we multiply our denominator, 3, times our whole number, 8. 3 times 8 is 24, plus 1 is 25 thirds. And we'll keep the division for a moment here. Then we go 9 times 1 is 9, plus 8 is 17 ninths. So we could check our work. 9 times 1 is 9, plus 8, 17. Now, as we saw earlier, we don't do division of fractions. We convert all our division to multiplication. This term stays the same, but we flip this. Now, when we do that, we notice now we can cross-cancel, and it's always a good thing to do that if you can. 3 goes into there once, 3 goes into there 3 times, because now we get 3 times 25 is 75 over 17. Now if we added these together, we'd get a 12. This would be an 8. So the rule of threes don't apply. And 17 doesn't look like it's going to go anywhere. So you've looked at it, you gave it your best effort, but now it says type an integer, a fraction, or a mixed number. Well, we can convert this to a mixed number, but we could just leave it as a fraction, because they said they would accept fractions. So we're going to put 75/17 in there. And hopefully we're right. Yes. Okay. So as we move on to some basic skills, we are asked here what's going on. Well, this is a shorthand form, which we call exponential notation, where this means 5 times 5 times 5 times 5. Now you could put that in your calculator, 5 caret 4, and this gives you 625. I happen to know that one there. $6.25, and we got that one right. And again, you'll have some like this where we are to substitute values. X is 1, Z is 3. So we can just do it here. 3 over 3 times 1. And it's good to show the work. You're going to write this down on your blue sheet. You're going to do the substitution. And 3 times 1 is just 3. 3 divided by 3 is 1. Anything divided by itself, so long as it's not a 0, is 1. So we'll put a 1 in there. All right, our next one is for a solution, and I think we're going on into maybe equations now, but you don't know. Oh, I want to stay on that one actually. So let's write this out here. Is for a solution to this equation. So again, strategy, I'd copy the problem down onto my blue sheet. And I put a 4 there. I didn't do a very good one, a plus there. And the answer is yes. Enter the sentence as an equation or inequality. Let x, use x to represent any unknown number. All right. Let's just read this and convert it from English into algebra. 1 increased, we'll use a plus symbol, by 2 equals, and again this word quotient just means a fraction, 9 and 3. So you would have to know that quotient is just a fraction. 9 divided by 3. That's what the word quotient is. Now, they're not asking you to simplify this. 1 increased by 2. Let's look at it. The sentence translates to. I'm assuming this is what they're asking, because they're not asking to simplify. They just want you to convert. So this is what I'm going to write. So 1 plus 2 equals, and I need a fraction symbol. I could use this too. Could write it as that. Let's see if they'll take it, because this is the one they're giving me. 9 divided by 3. Now theoretically they should take that. I would have written it the other way, but let's see what they take it or not here. Yes, they are. Okay. Again, this is sort of introductory work into chapter 2, but also was used in chapter 1. Here they want us to add this. Well, if you remember the rule, we subtract the smaller absolute value from the larger. So it would be 3 minus 2, and that gives us a 1. But then we are to use the sign of the larger absolute value, which is negative. So really it was like this. Now this one was super easy. I was showing you the way to do it, but otherwise just put negative 3 plus 2 into your calculator and you get this answer. Did I put it in there yet? No, -1. All right, now for this one, they're asking us to look at this chart, analyze what they have here. Negative net income results. When a company spends more money than it brings in, a certain company had the following quarterly net income during its fiscal year. Was the total net income, what was the total income? All right. So again, I'm going to take my calculator and you're going to write these out. And I'm just going to type these in. 3.6 plus 7. Now I'm going to go minus 12.8 minus 5.3. And I get a negative 7.5. So let's type that in there. And let's see if that's what they wanted. Yep. And now again, you could write these out and work them, but you are allowed to use a calculator. That's on your computer. Find the additive inverse or the opposite. Now, once again, the key here is, what's this operation? You have to take the absolute value of the -8, which is 8. So now you're going into this and you're going to say, what do we have to add to 8 now, once we've done the absolute value, to get its opposite, or that would equal 0? And the answer is a -8. Yep. And again, some evaluation of what we're doing. We have 9 minus, now watch this, I'm going to put my value for x in a parenthesis. You'll see why in a moment. And then this will be y is 4. This y is 4 plus 6. Now, since our value of x is a -9, and in this formula there is a negative, we have the case of, we read this the opposite of a -9, this will become positive. So we now have 18 over 10. And this reduces to 9 over 5. They do want you to simplify your answer, and that's what I'll put in there. 9/5. And that's that. And as we look at this, they're saying that we have a line, horizontal line, and we know in a sense that the sum of these two angles is 180, and these angles what we call supplementary. So now if we just subtract 76 from 180, I think I can do that in my head. That's going to be 104. That's what our y angle is. So the sum of these supplementary angles would be 180. So 104. All right. Now again, some basic operations. multiplication of fractions, you want to write these down on your blue sheet. And strategy, it's multiplication because there are no symbols between these fractions, so that means multiplication. They're both negative, so the answer is going to be positive. And we can do some canceling here. 8 will go into 8 once, 8 into 16 twice, 3 goes into 3 once, 3 goes into 15 5 times. So our answer is 2/5. And since it's positive, we don't write the positive sign. 2/5. 2/5. We got it right. Now again, some basic rules as we do our next to the last one in this, or our last one in this section here. Find the reciprocal or the multiplicative inverse. Well, our initial number is a -15. So the reciprocal of this is what we would multiply it by. So we end up with a +1. Now, keep in mind that every number has an unwritten denominator of 1. So to find a reciprocal, it will be the same sign, but now flip it. So now negative times negative makes it a positive. And here the 15s cancel out, and we get 1 times 1 over 1 times 1, which is 1. So the multiplicative inverse of this is a -1 over 15. So we put in our negative, put in our fraction, 1 over 15, and there it is. So this will be our first 100, the first 20 of our 100 questions in review for the final. Hopefully it's been helpful.